In this video, we're going to do a review of operations with real numbers, particularly with integers. So when we begin to talk about integers and about these values, one of the topics that comes up is the absolute value. Remember, absolute value is actually the distance from zero. And it will always give you a positive value. So for example, if I want to know what the absolute value of -3 is, -3 is 3 spaces away from 0, so my answer is going to be 3. If I want to know what the absolute value of 3 is, I want to know how far away from 0 is 3, which is 3 spaces. So 3 and -3 are what are called opposites. Well, that's supposed to be 3. Are what are called opposites. What's important to remember about opposites is they're actually what are called additive inverses. Additive inverses are values, okay, that add to 0. Okay? Since the identity property of addition is what number plus 0 basically gives it back itself. 0 is what's known as kind of like the identity number. So when I look at what additive inverses are, it's numbers that add up to give you 0, because I'm looking at addition. So the opposites, in this case, 3 plus then a -3 equals 0. So 3 and -3 are what are called additive inverses. Multiplicative inverses basically kind of are the same idea, except for we look at the identity property of multiplication. And instead of talking about 0, I'm talking about what number times 1 will give it back this number you started with. So 1 is actually the key figure. So I'm looking for what two values multiply to give me 0. Or to give me 1, not 0, because 1 is the identity. So when I begin to look at this, let's say I take 3. 3 times its reciprocal of 1/3 give me 1. So basically this here is what's called the reciprocal. I basically take the 3 and just flip it. Okay, I put it 1 over 3. So if I begin then looking at like a fraction, let's say I gave you 2/3. 2/3 times its reciprocal of 3/2 would give you 1. So that's what's called a multiplicative inverse. Quick review of adding and subtracting. Okay. For addition with integers. Basically, if I have a positive plus a positive, it's like the same thing we've covered. I'm going to add the numbers and keep the positive sign. If I have a negative plus a negative, I'm still going to add the numbers, but I'm going to keep the negative sign, keep the sign. So basically, if you have the same sign, I'm going to add the two numbers and keep the sign. So this could be seen by saying, okay, what's 3 plus 6? Well, it's going to be 9. What's -3 plus the -6? Well, 3 plus 6 is 9. Keep the negative. Okay. When I have a different sign, or different signs, keeping in mind that addition is commutative, so I could change the order, whether it be a positive plus a negative, or a negative plus a positive. Okay. Basically what I'm going to do is subtract the numbers and then keep what I call the larger sign. Keep the sign of the number with the larger absolute value. Keep the sign of the number that's the farthest away from 0. So in this case, let's take 6 plus a -9. In this case, I think 9 minus 6 gives me 3. Negative 9 is farther away from 0. The absolute value of negative 9 is larger than the absolute value of 6. So my answer is going to be negative. If, however, I wanted to do negative 6 plus a positive 9, this is like if I was having commutative property, I could just switch the order. I would get 9 plus a negative 6, which just basically becomes 9 minus 6, as we're going to see in subtraction. So negative 6 plus 9 is just going to give me positive 3. So I can think 9 minus 6, the 9 is farther away, okay, from 0, so it's going to stay positive. When I deal with subtraction, the good news is it's really just addition. If I can take the keep, change, flip rule from fractions, kind of apply the same idea. Whatever I have, so if I have 6 minus 9, okay, what I'm going to do is keep the 6, change the subtraction to addition, and then change the sign of the second number. So in changing this from subtraction to addition, I'm also going to change the sign of this number. If it's positive, it becomes negative. If I had 6 minus a negative 9, I would change this middle sign, but I'd also have to change that sign as well. So it would become 6 plus 9, which gives me 15. And the answer to the first is negative 3. So this is basically addition and subtraction. Looking at multiplying and dividing integers, the rule is actually easier. Okay. Basically, if I have if I have an even number of negatives, my answer is going to be positive. If I have an odd number of negatives, my answer is going to be negative. So what you can actually do, if it's all multiplication and division, you can go through and just count the positive and negative signs. So for example, a positive times a positive will give me a positive. A negative times a negative will also give me a positive. Positive times a negative gives me a negative. A negative times a positive also gives me a negative. So basically, here I have 2 negatives, which becomes positive. If I'm expanding this idea, if it's a negative times a negative times a negative times a positive, and I want to divide it by a negative. If I go through, I have 1, 2 negatives, those become a positive. 1, 2 negatives, those will become a positive. So basically, since I have 4 negative signs, my answer will end up being a positive. Okay. The same thing will apply for dividing integers. Just a caution, couple little minor things. If I have a fraction of negative 5 halves, this can be considered negative 5 half over 2, so negative 5 divided by 2, or you consider it as 5 over negative 2. Okay, it's got to be one or the other. Because my final sign ends up being negative, it has to be a negative divided by a positive or a positive divided by a negative. One other little minor caution, or 2 little minor cautions. If I have the opposite of 4 squared, the exponent squared only applies to the 4, so it becomes the opposite of 4 times 4. If, however, the negative sign is inside the parentheses being squared, that means I'm going to do negative 4 times negative 4, which is going to give me positive 16, whereas the first answer would end up giving me negative 16. Other thing to remember about dividing by 0 is that if I wanted to do 0 divided by 3, my answer would be 0. However, 3 divided by 0 would give me undefined or not possible. Okay, so if 0 is in the numerator, you're able to divide to get 0. If 0 is in the denominator, it's going to be undefined. Okay, hopefully this has been a helpful review to you, and good luck.